Have you ever looked up at the night sky, stars twinkling like celestial fireflies, and wondered where Earth ends and space begins? It's a question that has captivated humanity for centuries, fueling our dreams of reaching for the cosmos and exploring the great unknown. From the earliest days of stargazing, humans have been fascinated by the mysteries of the universe. Ancient civilizations built monuments aligned with the stars, and philosophers pondered the nature of the heavens. This curiosity has only grown stronger with time, leading to the development of modern astronomy and space exploration. We send rockets soaring through the atmosphere, breaking free from the gravitational pull of our planet. These powerful machines are a testament to human ingenuity and our relentless pursuit of knowledge. We watch astronauts float in the weightlessness of orbit, their bodies adapting to the unique conditions of space. These brave explorers conduct experiments that expand our understanding of the universe and our place within it. And we marvel at images of distant planets, captured by sophisticated telescopes and space probes. These images reveal the beauty and diversity of our solar system, inspiring us to dream of future missions to these far-off worlds. But where exactly does this magical transformation from Earth to space occur? Is there a precise point where our atmosphere ends and the vacuum of space begins? Is there an invisible line we cross, a celestial boundary that separates our world from the vast expanse beyond? The answer, my friends, lies in a concept called the karmanline. The karmanline, named after the Hungarian-American engineer and physicist Theodor von Karman, represents this boundary. It is an imaginary line, 100 kilometers, or approximately 62 miles, above sea level, encircling our planet. Imagine an invisible boundary, 100 kilometers, or approximately 62 miles, above sea level, encircling our planet. This, my friends, is the Karman line, the internationally recognized boundary between Earth's atmosphere and outer space. This, my friends, is the Karman line, the internationally recognized boundary between Earth's atmosphere and outer space. Crossing this line isn't just about reaching a certain altitude. Crossing this line isn't just about reaching a certain altitude. It signifies entering a realm where the rules of earthly flight no longer apply, where the thin veil of our atmosphere gives way to the infinite possibilities of space. It signifies entering a realm where the rules of earthly flight no longer apply, where the thin veil of our atmosphere gives way to the infinite possibilities of space. In this realm, traditional aerodynamics are replaced by the principles of orbital mechanics, and the challenges of space travel become apparent. Where the thin veil of our atmosphere gives way to the infinite possibilities of space. Here, in the vastness of the cosmos, we are reminded of our small place in the universe and the boundless potential for discovery and exploration that lies ahead. Imagine trying to define where the ocean ends and the shore begins. It's a gradual transition with waves crashing on the sand, creating a constantly shifting boundary. The ocean and the shore are in a perpetual dance, each influencing the other, never quite the same from one moment to the next. This ebb and flow, this seamless blending, is a perfect metaphor for many natural boundaries. Just as the ocean and shore merge, so too do the layers of our atmosphere blend into the vast expanse of space. It's a gradual transition, not a sudden change, with the sky slowly darkening as you ascend higher and higher. Similarly, the boundary between Earth's atmosphere and space isn't a hard line, but a gradual transition. The sky fades from blue to black, and the air thins out until it's almost non-existent. This transition is so smooth that it's hard to pinpoint exactly where the atmosphere ends and space begins. So, how do we define such a boundary? Enter Theodor von Karman, a brilliant Hungarian-American physicist and aerospace engineer. Karman was a visionary, a man who looked to the stars and sought to understand the very limits of our world. His work laid the foundation for modern aerospace engineering. In the mid-20th century, as humanity stood on the cusp of space exploration, Karman tackled this very question. He pondered the challenges of space travel and the limits of our atmosphere, seeking a way to define the edge of our world. His insights were crucial as scientists and engineers began to dream of reaching beyond our planet. He realized that as you ascend higher, the atmosphere becomes thinner and thinner, the air pressure drops, and the density of the air decreases. This thinning of the atmosphere presents unique challenges for aircraft, which rely on air to generate lift. At a certain altitude, the air becomes so thin that an aircraft would have to fly so fast to generate lift that it would essentially be exceeding orbital velocity, the speed needed to stay in orbit around Earth. This realization was groundbreaking, as it highlighted the limitations of traditional aircraft and the need for new technologies to explore space. Karman calculated this critical altitude to be approximately 100 kilometers or 62 miles above sea level. This altitude, now known as the karmanline, represents the boundary where aeronautics gives way to astronautics. It's the point where the atmosphere is so thin that conventional aircraft can no longer operate effectively. This point, where aeronautics gives way to astronautics, where wings become less important than rocket engines, is what we now call the Karman line. It's a symbolic boundary, marking the edge of our atmosphere and the beginning of space. It's a line drawn in the sky, a testament to human ingenuity and our desire to explore the unknown. The Karman line isn't just an arbitrary altitude plucked from thin air. No pun intended. It's rooted in the physics of flight and the very nature of our atmosphere. As we venture higher, the air thins out, offering less resistance. For an aircraft to stay aloft, it needs air to flow over its wings to generate lift. The higher it goes, the faster it needs to travel to generate enough lift from the thinning air. At the Karman line, this speed becomes so great that it surpasses the orbital velocity required to stay in orbit around Earth. In essence, you'd be traveling so fast that you'd be essentially orbiting the planet, no longer relying on aerodynamic lift but on the principles of orbital mechanics. Think of it this way: below the Karman line, you're flying. Above it, you're essentially falling around the Earth, held in a graceful arc by gravity. This transition from aerodynamic lift to orbital mechanics is the essence of the Karman line. Section 4. Beyond the Karman line. A symphony of human achievement. Reaching the Karman line is a testament to human ingenuity and our relentless pursuit of pushing boundaries. Over the decades, thousands of rockets, satellites, and spacecraft have breached this celestial threshold, marking milestones in space exploration. From the early days of the space race, when Yuri Gagarin became the first human to orbit Earth in 1961, to the daring missions of the Apollo program that landed humans on the Moon, the Karman line has been a symbolic gateway to our cosmic backyard. Today, the International Space Station, a marvel of engineering and international collaboration, orbits Earth above the Karman line. Astronauts from around the world live and work aboard the ISS, conducting research, observing our planet, and inspiring future generations of space explorers. Section 5. Pushing boundaries. The ongoing debate about where space truly begins. While the Karman line is widely accepted as the boundary between Earth and space, it isn't without its critics and complexities. Some scientists and engineers argue that 100 kilometers is somewhat arbitrary and that the transition to space is more nuanced. They point out that atmospheric drag can still be a factor even at altitudes above the Karman line, affecting the orbits of satellites. Others argue that defining space solely based on orbital mechanics overlooks other factors, such as the distinct layers of Earth's atmosphere. The debate highlights the inherent challenges of drawing definitive lines in a universe that often defies easy categorization. It reminds us that our understanding of space is constantly evolving as we explore further and learn more. Section 6. The future of UP. The Karman line and beyond. The Karman line, whether a definitive boundary or a symbolic threshold, will continue to captivate our imagination as we venture further into the cosmos. This invisible line, situated at an altitude of 100 kilometers above sea level, marks the boundary where aeronautics ends and astronautics begins. It is a place where the atmosphere thins out and the vast expanse of space begins to unfold. It serves as a reminder of our remarkable journey from the first tentative steps into the sky to becoming a spacefaring civilization. From the Wright brothers' first flight to the launch of Sputnik, each milestone has brought us closer to the stars. The Karman line stands as a testament to human ingenuity, and our relentless pursuit of knowledge and exploration. As we develop new technologies and push the boundaries of human exploration, the karmanline will continue to be a milestone in our collective journey. The advancements in propulsion systems, material science, and life support systems are paving the way for longer and more ambitious missions. Each new breakthrough brings us one step closer to making space travel a routine part of human life. It represents not just a physical altitude, but a testament to our boundless curiosity, our thirst for adventure, and our unwavering determination to reach for the stars. The karmanline is a symbol of our desire to explore the unknown, to push beyond the limits of our current understanding, and to seek out new frontiers. Who knows what wonders await us beyond this celestial gateway? The possibilities are endless. We may discover new planets, encounter alien life forms, or uncover the secrets of the universe. The karmanline is just the beginning of our journey into the cosmos. Perhaps one day, we'll establish outposts on the moon, send humans to Mars, and create self-sustaining colonies on other planets. These ambitious goals are no longer the stuff of science fiction, but are becoming increasingly feasible with each passing year, or even venture to distant star systems. The dream of interstellar travel, once confined to the realm of imagination, is now being seriously considered by scientists and engineers. With advancements in propulsion technology and a better understanding of the challenges involved, the prospect of traveling to other star systems is becoming more realistic. But no matter how far we travel, the karmanline will always hold a special place in our history as the point where Earth's embrace gave way to the infinite possibilities of space. It is a reminder of how far we have come and how much further we have yet to go. The karmanline is not just a boundary. It is a gateway to the future, a symbol of our aspirations, and a testament to the indomitable spirit of human exploration.